Welcome back, everybody, to another month of Ceph Developer Monthlies. This one's probably going to be nice and short and sweet. There are only about 3 blueprints that I see on the wiki page. I'm posting into the chat now the link where the blueprints or discussion points are listed. If anyone has other work that they are doing that they would like to discuss, as we're talking, go ahead and throw it in there. Should be pretty easy to do. And it just helps us kind of keep things all in one place as we go forward. Beyond that, I think everyone that we needed here is here. So, Sage, you want to take it away?
Sure. Yep. Okay. So the first topic is the BlueStore cache design. First, just a really quick update. The I/O path has been completely rewritten since JUN was released. The metadata structure is a little bit differently. You have logical references for the byte space of the object. Those point to blobs, which are actual allocations on disk. The blob might be compressed or not. It'll may or may not have checksum data associated with it. It might be referenced by multiple objects, in which case it lives in the B node instead of the O node. That's mostly it. The write path works. It passes all the unit tests. It's reasonably stable. I haven't run it through the Rata suite yet, but it basically works. It compresses. It does checksums. It's not super smart about some things. So there's a fair bit of work to do there, just to make sure that you don't, get really weird layouts that are inefficient or something like that. But there's a big to-do list of stuff to sort out there. But the biggest change is that in order to restructure the I/O path to do that, so that the wall path wasn't really complicated, we rely on a buffer cache that's managed by BlueStore, because in certain cases in the write path, we actually do a read to satisfy a write, and we need to be able to see reads that are part of the same transaction that aren't on disk yet. So the buffer cache is already in place. It's super simple. It's just a map of offset to buffer list, basically, although it's a buffer structure that has a buffer list in it. And a state that's like writing or clean are the only 2 states right now. The main piece that's missing is trimming. So once we have our own buffer cache, then the good news is that we can stop relying on the cache in the block layer. Right now, the block device abstraction is doing a weird mix of direct I/O and buffered I/O in order to get caching, which causes problems. So by having our own buffer cache that we manage ourselves, then we can get rid of that, which is good news. It'll simplify that interface. The SBDK NVMe driver will plug in without problems. Right now, it doesn't work very well because it doesn't have a caching layer, but this removes the need for any caching at the block layer. So that's all good. So the main gap then is that BlueStore needs to do efficient trimming. It needs to manage its own buffer cache. So we have a lot of things going for us in that we have access to all the hints. We can design whatever cache replacement algorithm we want or use whatever algorithm we want. We have hints about won't need or will need or don't cache that were pretty sloppy before when we had to pass those down to the kernel and we didn't have that much control over what the kernel was doing. For example, there's a distinction between don't let this particular operation affect your caching decision, which is I think the no cache hint, versus the range that I'm operating on, do not cache it, which might affect other operations, or would actually remove it from the cache if it was already cached because of somebody else. Before that was kind of glossed over. We treated them the same, but now we can actually do them differently. So that's all good, but we need to decide how the cache is going to work in BlueStore. So I made a few notes in a pad. I'll put it in the chat. There are sort of two main issues. One is how to structure the caches in general, and then the second is what algorithm to use for cache replacement for trimming. So I think the first one is sort of the main question. And I sent an email to the list earlier this week or last week, I forget, summarizing what I thought we should do. I've sort of revised my opinion since then, but let me go through the options. So the simplest approach is just to have a global cache, have a global LRU or similar structure for the whole BlueStore thing. And this is what the kernel does, more or less. Mostly that sounds good. It's a single pool of memory that's being managed that can be used, and sort of all data that's touched by any collection is sort of treated fairly within the same pool. The problem with it is we might have multiple cores or sockets, even worse, sockets touching, mapping to different collections doing operations. And so if you have a global LRU, the cache lines that control the LRU list might be bouncing between sockets, to slow you down. It also means we have to have locking surrounding on that. So we have to take a lock, move our position to the top of the LRU or whatever it is, and then release a lock on each operation. And I'm worried about that being slow. So that's sort of the obvious solution that I think is not ideal. So to avoid that, the email I sent was proposing a per collection caches. So we already have an O-node cache that's per collection that's protected by the existing collection lock, which means that all the access to the cache is, there are no new additional locks. We're already protected by a sort of a big lock on the entire collection. And so we can just do whatever we want without worrying about taking additional locks, including moving around in the LRU. And so the current code does the same thing for the buffers too. So it's still a per collection buffer cache. Basically, each collection has its own independent LRU cache structure. And currently, you just configure a global limit per collection. So each collection is 30 megs or whatever, and that you have to do some arithmetic to figure it out. That has some obvious problems because you might have 100 PGs collections on the OSD, and your workload might not be distributed evenly across them because different pools will have different data, or maybe you have a couple hot objects that are in like 2 placement group collections. And so my original thought was we could, over some period of time, sample the number of operations that hit each collection and compare that to the global total number of operations, and use that ratio to give that collection some proportion of the total amount of memory. That way each collection's cache can still operate completely independently without any new locks, and is sort of sized appropriately. Which I think is mostly, that could work. The trick is that you have to choose a period that's sort of reasonably long enough that you get sort of a reasonably accurate sample of what proportion of the workload that collection should get. But isn't too long so that you can adapt to workload changes, so that the cache utilization can shift to different collections if IO shifts to a different pool or something like that. But that could be done. But the main thing that I was struggling with there is you could have collections that are idle, like maybe a pool is getting no IO currently for some period of time, and so you don't want to set its cache size at 0, because then it can't really function almost at all. Or maybe you could, I don't know. But the boundary conditions just sort of worried me. So I was trying to figure out if there's a better way. My third idea is to, instead of effectively sharding the cache for every collection, so every collection has its own independent cache, instead have an explicitly sharded cache where you have n shards of the overall cache. You assume that the collections are distributed over the shards uniformly. So each shard is one. If you have n shards, they each have 1/nth of the memory. And then map the number of shards to the number of shards in the op work queue, which should be the number of actual CPU threads that are accessing that are actually doing operations on the collection in the first place. And possibly pass some hints down. My thinking is that if we actually line those up, then we can add a lock that surrounds just the cache structures, but it's only ever going to be accessed by the same CPU core that's actually doing the operations anyway, and so the locking won't actually have any significant overhead. And then yeah, so that's my current thinking. But I want to get feedback before we go down any of these roads and see what people think. So does anybody have any comments, questions, suggestions, thoughts on those three approaches?
You know how you want to sort of partition the different PGs into, or collections into shards?
My thought was that we would add an interface so that they would partition the same way that the opwork queue is doing it. So I don't know exactly what the interface would be, but it would just so if whatever the mapping of PGs onto the opwork queue shards, it'd be the same mapping for the corresponding collections for the cache shards. So you know, if you have four work queue shards, then you'd have 4 cache shards, and they'd be on the same cores. Hopefully, most of the access. I think Sam, if you're here, maybe you can help me here. I think that's true. Most of the work in BlueStore is done synchronously in the queue transaction path. That's when we're preparing the write and fiddling with the cache for the most part. So I think that makes sense. It'll be the same execution context that's doing the preparation of the operation. The exception is IO completion. Right now, there's all that stuff gets shuffled into a single finisher thread that's pulling AIO completions off the queue. And in the write case, that has to update the cache from the writing state to the clean state. And in the reading case, it will actually, well, we don't have AIO reads yet, but when we do, that completion context will also do the same thing. It'll update the cache. So maybe the answer is that the AIO completion should also be sharded in ways, so that which we can do with multiple AIO queues. We could have each of those work queue contexts, whatever, using independent AIO queues, and those queues could have independent finisher threads that are hopefully pinned to the same core, so that we don't have any of the blocks bouncing between cores. I think that makes sense, but probably somebody who has more experience with doing the multiprocessor thing would have more input. See, Sam, are you here? I think I see you on the call, but I don't hear you. Yep, you are. You're muted. Maybe that's why I can't hear you.
But now?
Yep, that's better.
All right. Okay, it makes sense to me.
Okay. This makes me think if we actually want like a third primitive in the object store interface that sort of explicitly defines these execution contexts, so you can assign collections to like a thread and a thread pool or whatever. That way, so we can do these AIO completions in the same context as they're submitted in.
Yeah. The design I was throwing around for the AIO read stuff involved passing a completion context to the file store. Mm-hmm. So we could extend that concept to some kind of generalized cookie that the object store could then use to allocate its own context.
Yeah.
I don't know. it may be more work than it's worth to try to keep the threading context separate. It may make more sense to just jump,
Hint or
well,
switch
just jump fully into SPDK or equivalent, and see if we can't use their abstractions.
Yeah.
I didn't think it was a good idea at the time, but the more complicated this gets, the more it seems like it might be. We should probably investigate the interface. I haven't looked at it much.
Yeah. Yeah, I haven't either. Okay, well, maybe the thing to do is keep it minimal for now. So focus just on the submission path, so that we map collections onto shards in the same way that the opwork queue does, and not worry about completions. And then as we figure out more on the SPDK side, yeah, go from there. So does it? Everybody agrees on the sharding makes more sense than the per collection caches?
Yeah, that makes me a lot happier.
Yeah.
Oh, I didn't. How does this contrast with the per collection caches? Sorry, I walked out of the room to get the microphone.
Okay, so the per collection idea was that you would sample over some period of time, maybe 5 or 10 seconds.
Yeah, to allocate the cache size.
And then you'd set each collection's cache size, and then it would work locklessly. So this,
how does
the sharded queue is, say you have 5 opwork queue shards, you would hint that down to the object store so that you'd also have 5 cache shards. And
so you'd have 1 cache per shard and assume that it's evenly distributed. Okay, I get it now.
Yep.
That makes more sense.
Or, I mean, you could build a balancing algorithm on top of them, but you really shouldn't need to.
Yeah.
No, I think it's safe to assume that it's balanced.
Yeah, we have many more collections than shards, I guess. And my understanding, I think I just noticed this when I was looking at the RocksDB pull request that's enabling all the RocksDB row and block caches. Their block cache also has a shard count. So I think they're doing something similar, where they just break the whole cache into n pieces and let them function independently. It does mean that we need to protect all the cache operations with a lock, but my understanding is that those locks should basically be free because they're always taken from the same context, the same core. Is that true?
Uncontended locks are cheap.
Yeah, okay.
I don't know whether they're cheap enough. If they're not cheap enough, then we can do something more creative.
Yeah, it should be.
But the hard part is usually making them uncontended. The easy part is making the locking primitive fast.
Yeah. Well, they should be uncontended. So that the contending piece is going to be trim, if the trim happens from a different CPU context. But I think in general, trim will happen under the same lock that you're adding stuff. You'll just also kick stuff off the end at the same time. You already have the lock, so I think it'll be okay. What I was worried about before was trimming in the per collection case, where you don't want to be kicking things off for a different collection and have to take the other collection's locked updated data structures or something. But if they're in big shards, then we'll just trim locally, and I think it'll be fine. Okay. Shards it is. So that's the first thing. The second issue is just what algorithm we should use. I've done a little bit of reading over the last few days to try to figure out what algorithms are out there. There's a 2Q algorithm, which is like sort of a double LRU. The paper is like a scan, so it's at least 15, 20 years old. I'm pretty sure multi-Q is basically a more generalized version of the same thing. Multi-Q looks pretty promising. I haven't read the whole paper, but it basically has n LRU lists. And the idea is that when you hit something, it moves to the front of its local LRU on the same level. And then you maintain a count of how many times you've had a hit. And once you hit the threshold for that tier, then you move up to the next tier. And the next tier's threshold is like twice the first one, and then 4 times and whatever, it's the power of 2. So each level you move up, it's like that many more times it gets hit that much hotter, and it's harder and harder for it to get pushed out of cache. I like this one because we have a whole bunch of sort of tiers of access that we can steer to, like, put them in a particular queue when they first get added to the cache. So for example, if we have a read or a write that has no hints, so we have no idea whether it's going to be useful in the cache or not, we can just put that at the base level. If we have something that is, or maybe the second level, if we have something that is hinted that it shouldn't be cached, then that can go at the very bottom level, or probably just kicked out entirely. If we have something that says that it will be cached, we can put it up at like sort of a second level. And maybe there are other heuristics that let us decide that it should be up or down or something like that. And I think that'll let us sort of opportunistically use our memory to cache things that might be useful while still ensuring that things that were hinted as being useful, like, put them a sort of a level above that, which we can't do with just a straight up LRU. There's an ARC algorithm that I don't know much about. People like it because it's self-tuning. So it has, I think, two LRU lists, and it sort of dynamically tunes the size of the first one, the second one. But in my 2 minutes of Googling, ZFS adopted it and then Postgres adopted it and then promptly kicked it out because they were worried about an IBM patent on it, and they started using something else. So maybe we want to just avoid that one, just because. And there's also another one called LRS. There's another one too. I'm forgetting. But those ones have this. There's a whole class of them that have this secondary structure where they basically track the metadata for pages that they've already evicted. So they have like an LRU of stuff that isn't actually in the cache anymore, that was kicked out. That's like the second chance. So if it was evicted and then it gets added back in again, it'll realize that its reuse distance is like just larger than the cache, and it should get a second chance or a higher priority or something. But it's more complicated because you have to maintain this metadata for stuff that isn't in the cache for some period of time, and we'd have to putz around with how we deal with that. So
that just allows you to extend your reuse distance memory for longer than your actual cache size.
Yeah,
that makes a certain amount of sense.
Yeah, it assumes that the metadata is cheap compared to what you're actually caching, which is probably generally true. Our cache is a little bit different because the buffers are sort of arbitrary size. It might be a 4 meg lump, or it might be 30 bytes if you have a really weird workload. And most of the algorithms are sort of assuming like fixed size pages. But my sense is that it probably won't matter very much. But who knows? We'll see. I think worst case, we could just have a max size of a buffer and at 512K or something like that, and just chop it into pieces so they can have independent life cycles or something. MFU, most frequently used. Yeah, maybe. So I mean, I'm kind of looking for anybody who has done reading on this or wants to go research all these algorithms. Somebody put in a link.
I mean, the last time I read a lot about these, the bottom line was that you figure out what your workload is first, and then you research the algorithms. If you don't know anything about the workload, then you use something very simple.
Yeah.
We don't have special information about our workload.
We sort of do. We know it's a second level buffer cache, and a lot of these algorithms are designed specifically for second level caches. For example, multi-queue is, where you have a sort of a first level cache somewhere in front of it. So that's good. And what I was reading out of, I can't remember if it was the multi-queue or one of the other papers. There's one called clock something. It was a variant of clock and something else. I don't know. But they're making a distinction between two types of workloads. There's the type of workload where you have exclusive caching, where it's like any particular piece of data, there's going to be one client accessing it, and it's mostly a matter of making sure that you coordinate with the cache that's sitting above it. This would be the RBD case, where there's no sharing, basically. And the other workload is where you have non-exclusive, inclusive caching, I think they called it. And that would be more like RGW, where you have multiple clients accessing the same data, and you're doing that in the hopes that some other person will see it. And understanding that distinction changes a bunch of stuff. I don't know. Like the reuse distance for exclusive caching is always going to be longer than whatever the cache is sitting above it. Whereas if you have inclusive caching, multiple clients accessing the same data, then it might be shorter depending on what your locality is between clients or whatever else. So yeah, I don't know. I guess the question is anybody interested in this, or should we sort of pick one at random that's reasonably simple and seems to suit our needs? Because if it's the former or the latter, my choice would probably be multi-queue, because it's conceptually pretty simple, and I think it satisfies the set of requirements that I understand, at least, which is just using the cache insanely so that we can insert new data at sort of an appropriate tier in the cache, in front or behind other things. That's MQ, multi-queue. Multi-queue will allow you another per queue stuff. Yep. The other nice thing about doing multi-queue is that I think it would also work well for the metadata server, which right now is sort of a 2Q. It's a dual LRU, but it's not doing anything particularly smart about it. It's sort of the same, it's actually one LRU with an insertion point in the middle. And I think the multi-queue thing where it counts and moves things, it counts within a tier before it moves up to the next tier, would be a significant improvement over that. So if we're smart about the implementation, we could use it in both places, potentially.
Sage, I'd say start easy and then reevaluate whether or not the easy one is, bad or crappy in some way, right?
Yeah. Yep.
And building what Sam said. We don't really know. Start easy, see how we do.
Yep. Okay. Sounds good. That's all I have for cache stuff. Any questions, comments?
My experience is that if you start with caching, you get a fast result for about 80% accuracy, and the last 20% is going to take you almost forever to get to the point where it's optimal. So
yeah,
well, I did it for a PhD study, so in the 80s. So you can spend 4 years on it and then get a degree.
Yep. Well, if anybody wants to do that, be my guess. Yeah. Okay. Okay, that's it on BlueStore then. The other topic is the Messenger 2 protocol. I really hope Marcus is here. Is he here? Is somebody here who can go find Marcus?
Marcus in the Ann Arbor office?
Yeah.
Yeah, let me go poke him.
I should have poked him earlier. So the other topic is around the new revision of the Messenger protocol. There was an email list I started last week or the week before last, just with sort of a strawman proposal. But several questions to answer there. I think the main thing, for those that were following the discussion, the main thing that I'm unsure about is how to deal with I guess a downgrade attack, where you want to make sure that dropping messages from the exchange doesn't prevent you from, initiating encryption, for example, or something like that. And I'm curious how most existing protocols do that. I can sort of imagine what we might do, but I assume we should sort of learn from what other protocols have done and not just operate from First principles. Is anybody here who is familiar with this, or should we could maybe jump to Calamari first and then come back to this?
Yeah, I think that's probably a good idea. We're giving Marcus a call right now, but he'll be a little bit, so come back to it.
Okay.
Hey, so we're ready to do this topic?
Yep, go for it.
Great. Cool. So I wanted to put this one on the agenda just so that I could try to set everyone's expectations and answer any questions and kind of open it for discussion. And dispel any rumors. You saw that I had added rumors to the agenda. The juiciest one is that Calamari is dead. I guess that's not really true. Calamari used to mean a lot of things, and it is kind of just a name. And so I want to kind of, reiterate what I believe is living on, and then kind of talk about what might not be. So first and foremost, the Calamari project on GitHub is still active. The latest branch is the 1.4 series, and the kind of primary ideas behind it are stripping down the dependencies that made it heavyweight in the past and removing the salt communication channel. I think John Spray's alluded to this in a couple CDMs past. So basically there, instead of depending on salt master and salt minions and their encrypted ZMQ channel to serve as kind of a way to talk to all the different Ceph nodes and get their status and give you cluster health. It's been stripped down, and now it really just talks to the monitor on the monitor node. So it can run converge with a monitor node and gets its updates that way. So the benefit there is it's a simpler design. The drawback is it gives away some of its command and control possibilities that we never did much beyond just conceptualize. So it's kind of living on as a way to get cluster health and provide a REST API for the stuff that is already documented on calamaryreadthedocs.org. So kind of the headline there is we're keeping the same API that we had and that's documented, and that piece is living on, and we're trying to shed some of the dependencies, and namely salt. So development's happening in the 1.4 branch. Check it out, of course.
And I think probably the thing to emphasize there is that this converged design where Calamari sits on the monitor node is standard in JUL.
That's right. Yeah, that's definitely a great
still
point.
Not part of the Ceph. It's not part of the Ceph packages themselves, but it's installed alongside JUL, and it'll be that way in the downstream.
That's right. So that's a great point. That's where we're planning to go with our next downstream release. And there's also been talk about how this functionality lives with Ceph Manager, and I think that's kind of a topic of interest there, in that Ceph Manager could provide a runtime for Calamari to run, since Calamari is really just a Python process that provides the REST API. I see you by the video, John. Maybe you want to say something.
Hello. Yes. So the thing I think that needs clarifying, and I don't know if we have the answer to this or not, is that if you're keen for Calamari to live on, then we're going to have questions about where people send their code, whether they add it to the REST API that is a descendant of Calamari inside Ceph Manager, or whether you are inviting people to continue contributing to Calamari.
Mm-hmm.
So, I mean, I think the question is that a cutover, or is there a genuine intention to keep Calamari going post Ceph Manager?
So that's a great question, and I think the answer is, we really haven't decided yet, and maybe we can, talk about it more here. I don't really see a whole lot of reason to keep it on as any kind of separate project. I think, we're moving back. I think the intention is that we're moving closer to Ceph so that the code lives closer there. Naturally, where the code gets contributed is going to be a function of, well, what are you trying to accomplish, right?
So I think when people want to add stuff to a REST API, it's going to be less a case of what they're trying to accomplish and more a case of which repo do I send my pull request to. So I'm not sure there is, I think there is probably a need to maintain Calamari as it's currently used in downstream Ceph distributions. From my point of view, I think at the point that we've added Ceph Manager and Kraken, I'm not sure that we really do want Calamari to live on upstream. I think it would probably be better to put it into more of a maintenance mode.
I agree with that. And focus efforts in one area.
Yeah, I mean, it makes sense to me. I think, from the standpoint of, to represent downstream, the message we've been trying to, drive to everyone there is that we're just trying to provide a stable documented API, and wherever that gets provided, we're not really really concerned about. It's just that if people want to build on this thing, it would be nice if we committed to trying to keep what we have available. And so if upstream it has to move to a different repository, that functionality, then I'm totally on board with that.
So the REST API code in Ceph Manager is largely the same as what's in Calamari, but it is not 100% identical. So there's nothing that's like changed gratuitously, but it's things like Calamari supported multiple Ceph clusters, whereas Ceph Manager belongs to a single Ceph cluster. So like all the URLs that used to start with an FSID just kind of don't anymore, that kind of thing. So I think when we're talking to people about this, it's important that we're clear that it is not going to be a exactly compatible API. We're keeping the code around, we're keeping the same those endpoints that still make sense. But in terms of that overall story of providing people a stable API, that is an aspiration. It's not actually what we're about to do. What we're about to do is change the API. But at the point that we changed it, we'll be in a better place to have it be stable in the long run.
That's fair. So I wonder, in that specific example, not that I want to try and refute everything so that we remain compatibility, but it also seems like, okay, yeah, that's fair. A single cluster is kind of the provision of the stripped down, Calamari 1.4. Would it be fair to say that maybe we provide that same URL structure and give it a deprecation notice so that it really just points to, the places we want it to end up?
I'm not sure I see the point. I think we've got like a couple of things out there that use Calamari, and we could add code into Ceph Manager that made it do a slightly better impression. But it's not just that one thing with the FSIDs. So like, hang on, I actually have a list of things that have gone. So like, for example, all of the stuff that was under the V1 API tree is just gone because it's ancient.
Well, I'm not worried about that stuff for sure because it's not documented in read the docs. So
okay, things like there's other stuff that just kind of didn't make sense anymore. Like if somebody goes to server/grains, obviously there's no salt anymore, so that stuff's gone. We don't have anything telling us. But when we're just inside Ceph, we don't have anything that tells us the network interface names in the machines. So like the front-end interface, back-end interface members on the server is gone. The stuff which used to live in database tables, so Calamari had a database table of events, which was like its own little log, and Ceph Manager just doesn't.
Yeah, not to do
that's gone. So I think at the point where there are all those, that was half my list. So at the point that there are all those changes, I don't think having redirects to deal with the FSID thing is really going to be useful to anyone.
Okay, I think that's fair to say. Then probably the right thing to do is to, summarize these differences on the list and see who actually does care. And then, I'll make my decision on how to treat Calamari, going forward on that. I mean, I think the answer upstream is let's go with what you're proposing, and of course the reality is that I'll have to provide support downstream for the time that we've signed up for. But I think as long as that we're sending some pretty clear messaging upstream, I think people will be able to swallow most of that stuff.
Yeah, and I mean, it's all open source, so if anyone decides that they really do want to keep using the old Calamari code, then something's stopping anyone. But I think we should probably be clear with people that at least within the core Ceph team, none of us are planning on doing anything with it. So people can send pull requests, but there won't necessarily be anyone reviewing them. Actually, speaking of pull requests, so the RBD pull request for Calamari, is that something you're working on getting merged, or is that kind of in limbo?
Let's see. Are you talking about one to flesh out the API entirely? I know someone's been working on doing cache pools, but there's also a pull request for RBD.
Yeah, there's a pull request which adds a whole RBD management bit too.
I mean, I think it's fair to say, but it might be better to say, this fits more in with Ceph Manager code base if you think that. But maybe, where would you put it?
Well, so what I'm probably going to do is look at the changes that have gone into Calamari in the last 6 months or whatever. And because the code that's currently in Ceph Manager is not the very latest tip of Calamari. And there are sufficiently few patches in Calamari that it's not a big deal to go through by hand. But with things like RBD, it's either going to be a case of bouncing it back to the person who submitted it and saying, you have to retarget this for Ceph Manager, or if it's simple enough, I might, me or someone else might pick that up and by hand sort of port it over, because we need to make sure there are enough hooks in Ceph Manager for this code to work. But that's a really good example of the kind of thing that we have to work out how we're going to deal with.
Because we'll say the message, but people have to, we have to make it a reality by.
Yeah. So if we are with things like that going to redirect people to Ceph Manager toward the end of the Kraken cycle, we should probably say something to them now, to let them know whether they should still be working on this for Calamari, or whether we're asking people to pause and come back to us in a month or 6 weeks or whatever, once Ceph Manager is in master Ceph.
Yeah, that's a great point.
So, I guess my kind of, from the Ceph Manager point of view, my kind of message at the moment is still kind of, hold on a second, just give me a second, and we'll get it in master soon, and then all this train can start moving.
Pay no attention to the John behind the pull request.
Yeah, but I think that might be a little bit incompatible with talking about Calamari being alive and well, because if we're actually not accepting pull requests for Calamari, then that has to be the message.
Yeah. Okay, well then, I think that it makes sense, from an upstream perspective, we should probably redirect it to Ceph Manager. So I can evaluate, what that'll take.
So yeah, I don't want to particularly speak for Calamari, because if anyone is still working on it and wants to still work on it, the fact that we have Ceph Manager doesn't necessarily stop them. But at the same time, we should, tell people if we're not accepting pull requests on it anymore.
Yeah, the challenge, of course, is definitely the upstream downstream split, right? So from upstream perspective, we're going to go with this, and the downstream is based on JUN. So whatever we've shipped there, we're going to support for the 3 or so years. So we'll still have to do bug fixes, but yeah, as far as features go, I think it's a case where we're going to want to direct the things that make sense to Ceph Manager, and it may still be the case where we do some minor things downstream where they don't make sense. But does that make sense?
Yeah. Sorry, I didn't mean to completely derail you. I just wanted to make sure the Ceph manager part of it was clear.
No, I think it's important because that's a discussion we kind of owe to the community. Is what are we doing?
Actually, just I'll add a question. So, for ongoing maintenance of Calamari, I think we currently don't have upstream packaging and that kind of thing. Or are you going to add that, or are you going to leave that as it is?
I've said in the past that I'm going to do it, and it turns out that I'm not really good at wanting to do packaging. So I have a better answer for the community, which of course is a go do it yourself, but it's a good supported go do it yourself. We have jenkins.ceph.com, which you're probably all aware of, but we also have this project now called Ceph Build, which is part of the Ceph organization on GitHub. And that project aims to configure Jenkins using code. So basically, you can make pull requests against Ceph build, and it will configure Jenkins job builder to do basically whatever it is that you want. And in this case, what we'd want would be to build the Calamari package. And there's some kind of crufty code around there that's pretty close, but it needs to be taken over the line. So if there's a lot of interest in that, I would say I would love help there because I'm notoriously bad at producing upstream packages.
Okay, so you're saying the possibility is there, but there are no concrete plans to do that.
Right. That sounds like a nice one. If we do the Ceph manager transition sooner rather than later, then we don't have to worry about it.
Exactly.
Yeah. Okay. John, you said 4 to 6 weeks. Do you have is that sort of a rough, just so people have some vague sense of what?
Well, let me just make a commitment. So, right.
The one useful piece of information here.
Yeah. So the current state of the branch is pretty healthy. It has its new monitor component. The actual failover part of that isn't in yet, but the infrastructure is. My outstanding list of sort of must-haves before actually going into the tree are to create some tests for it. So what I'm probably going to do with that is generalize the Python test stuff that I did for Ceph, but kind of starting and stopping the service and making sure that it at least basically operates. It doesn't have to be completely complete. I would like to merge it without any tests at all. And the part of the Python interface that I haven't defined yet, I want the Python interface to be able to do Ceph-style CLIs so that the Ceph CLI can drive it, and you're not limited to just what you expose through a REST API. And then there's the placeholder thing for passing PG data into plugins, so that the Calamari API for things like creating plugins can actually operate. So I would say a month from now, this will be a pull request.
Okay. All right. Anything else you want to share on that before we move on?
No, I'll send another status update to the list soon as well with the latest code.
All right. Sounds good. Thanks. Okay. So coming back to Messenger 2 then, I just pasted the pad link into the chat again. Pull up the email thread too and see what was discussed. Let's see, Hama had some questions about compatibility. This will definitely be incompatible with the previous protocol, which means we have sort of free reign to do whatever we think is appropriate. We talked a bit about signatures and probably adding those into the message header, or at least part of that overall exchange, so that we can reduce the number of socket calls into the network stack to pull out a signature. We can do it along with all the other data that we're pulling off. That'll be a small efficiency win. Let's see. Marcus asked about the feature exchange in sort of the banner. My thought is that these would be sort of a second set of features, not necessarily Ceph features, but messenger features, protocol features. So we can have a new set of bits that we define specifically for changes in that protocol, and add things there. And we can define which ones we support and which ones we require, so that during that handshake you can figure out that you don't support something and therefore you should hang up or go somewhere else or whatever. So I think that's fine. I guess the main thing we'd have to be careful of there is that whatever authentication handshake happens after that should probably re-verify that information as part of the exchange, because so that a man in the middle doesn't tweak the features that you claim to support and prevent you from attempting to do X, Y, or Z. But I think just as part of the authenticated, encrypted exchange or whatever it is, just as long as you echo that same information, you can tell if it's been tampered with. Let's see.
How does that work if you've been downgraded?
If you say there's a feature, I support encryption, that they say that they hide, when you do the authentication handshake, you would repeat that same feature information. And if it was different because they tried to downgrade you, then your authentication handshake would fail.
Yeah, but if they downgrade you, then you're not going to be encrypted. And so they can still change your replies.
You would still be doing the authentication handshake. So unless you don't require any authentication at all, but like nobody was going to run that way. So yeah. I think we assume a baseline of some secure handshake for authentication, and that's the pluggable thing, where it's either CephX or CephX2 or whatever we call it, or we could add Kerberos or none or whatever. Yeah. Let's see. Yehuda had some suggestions about pipelining, which I think make sense, where you sort of try to send as much stuff optimistically as you can to limit the number of times you're waiting for a back and forth exchange. I think it makes sense. When I was sort of writing this up, I was sort of unsure about how flexible to make the protocol, as opposed to like defining very distinct phases and a regimented like back and forth exchange. I think making it more flexible means that we can do things like pipeline. But I'd be curious to hear other people's feedback on if it's sort of too loosely defined or too sloppy or whatever. Like one change I made originally was you would send a tag that says, tell me what methods you support, and it would reply with the methods you support, and then you'd set a particular authentication plugin method to use after that. I think we should just have it when the server answers that just broadcasts the methods so you can avoid that, would be one option. The other option would be that the client just tries to set its preferred method, and if it fails, then it looks at the methods and tries to negotiate another one. Maybe that optimistic thing is simpler. I don't really know. I think it could go either way. But I think
historically, it's probably better to give the server the final say on what method from a variety gets picked, just because the server might get upgraded more frequently and the client might not know that certain ones have been deprecated.
That's true. The server can deny it, at least, if it's been truly deprecated. But
the downside of having the server decide is that the client probably actually knows more about the kind of network it's attached to, and that's more likely to be the end of the network that would be insecure or slow or have other issues that the client might like to decide about. So I kind of prefer to have the client actually choose that.
let's see. While we're talking about signatures, yeah, I think my preference is also to have the client decide. The server can, as a matter of policy, you can configure which authentication methods you allow, and as long as you choose one of those, then you're free game, and the client can just pick one. Yeah. Okay. Let's see. So the other thing was, so the main question I have, let's talk about signatures last. So the main question I have is around these downgrade attacks. So my thought was that, sort of going through the pad, I don't know if you have this open, Marcus, but you have these initial exchanges that where the client says, I'm going to use this method, and the server will say, okay. And then you have this sort of generic encapsulation where you send an authentication message to the server, and the server replies with some reply. And that's going to be defined by whatever plugin it has. That's the part where you either say, hey, I already have this ticket, let me use this to establish a session, or you say, I don't have any ticket, let's do some, exchange with a nonce to like authenticate ourselves so that we can create a new session ticket or whatever. That would all happen within the confines of that message exchange. And then my original thought was, once that's done and you have your session established, either using an existing ticket or by creating a new one, then you would send a message that says, okay, just FYI, from this point forward, everything that I send you is going to be encrypted. Just as a marker so that you switch from the sort of unencrypted portion of the exchange to the encrypted portion. And then you go from there. My concern was that whether we need to worry about a downgrade attack, or maybe there's some like subsequent portion of that exchange, like maybe the first few keys establish your identity, and then the last authentication auth reply gets a new ticket for some other service, or maybe it does something that modifies the way that you're gonna. Maybe it's the part where the client says, I want to do everything encrypted, or don't. And we want to make sure a man in the middle can't drop just that part of the exchange and then sort of fake the rest of the session. And I think the only way I think to do that would be that instead of having an optional message that says, I'm going to start doing X, I'm going to start encrypting, you would always have a final message that says, I'm done with my entire initial handshake. And maybe you have the optional thing before, but there's always something that bookends the exchange so that you can tell if something's been dropped. And that last message would say, we've passed 12 messages back and forth, and their signature was X or something like that. So you can tell that somebody tried to drop something out of the exchange. It feels kind of awkward. I'm wondering if this is how other protocols will do it, or if there's sort of a well-established pattern here that we should follow.
So the other protocols I've seen doing this, typically the handshake is a required part at the beginning of the conversation, and once you've done the handshake, then you go on and use it as a regular connection. Mm-hmm. So there isn't usually an explicit marker thing. It's usually just it's done with the handshake. It starts the regular stuff. Okay. There's some protocols that allow you to do both encrypted and unencrypted messages in the same data in the same connection path, and so that means each individual message is marked with whether it's encrypted or not, and so that's a possible option.
Do you think that's useful?
Well, there is one case that you might want to think about, and that is suppose you have credentials that have a limited lifetime, and you want to be able at some point do another handshake process to get a new set of credentials and continue on with your session, but with new credentials.
Mm-hmm. Yeah.
Or I guess another case to consider about is you might want to use one connection with several different sets of user credentials, for instance.
Okay. Okay. I was sort of assuming that if we had those sorts of exchanges, those would be layered on top those would be additional messages.
Okay.
So maybe this low-level messenger exchange would authenticate yourself to the monitor and authenticate that specific session. And then the part of the exchange where you say, by the way, I want to get all these other keys so I can go talk to OSDs and something else. That can be just regular IMAUth messages, kind of like they already are. That can be outside of this low-level handshake. If that seems reasonable, looking at you, Greg, then I think we could safely simplify this so that we always have this handshake process, and then it ends, and then thereafter you can't sort of modify that state.
I'm thinking about how this might work in terms of if we wanted to blacklist a client on the cluster. Because sort of the naive approach would be that we force a cluster key cycle that would require all the connections to re-authenticate, like across the cluster. And I'm not sure if and if that wasn't supported at the low level, I'm not sure that we could do it.
I mean, we could just close them. Like that's the sort of the easy thing. We could close them.
When you're talking about blacklisting a client, you're talking about some kind of automatic process, or you're talking about some sort of administrative action?
Administrative probably, but it could be semi-automated. I mean,
we have this client and we want to deny access to this client key, basically.
Yeah. Revocation.
And right now, the way it works is not great.
They just can't open new connections, basically.
They can't open new connections, but any existing connections live on until the rotation period ends.
Yeah, having a forcible disconnect is an uncommon choice in file systems, I would say.
Yeah.
Well, I mean, every file system needs a way to kill a client if you don't have stoneth. So.
I'm sorry, if you don't have what?
Stoneth.
Shoot the other node in the head.
I mean, yeah. I mean, the two cases are either A, you're going through and you're modifying authorization rights, and that usually doesn't involve forcibly disconnecting people. That just usually involves changing authorization rights. And the other use case is, I guess, a misbehaving client or something, just malware of some sort. And usually, it's uncommon for sites to have a real-time response to that kind of process. I mean, it's cool if they do, and typically, if they do have a real-time response, it's more likely to involve a firewall or something pretty gross rather than something that's inside the file system.
So the bar is low. I guess that's good. I think I would probably be satisfied here with just disconnect them and make them re-authenticate. That's probably good enough. And that way, I'm worried about the complexity of having sort of a say, please renegotiate your authentication handshake in the middle of an ongoing exchange and like changing keys and who knows what sort of follow-on effects that's going to have.
Yeah, the most common authorization decision is adding rights for somebody to look at something new. And usually what actually happens in protocols that don't have a real-time process is the person running that client decides they want those new rights and forces a re-authentication at that level.
Yeah. Okay. Okay, so if we simplify this then so that you do the exchange and then you have some defined point where you're done with the handshake and then you carry on with the session where you're actually exchanging messages. I guess the question is what's the right way to do this to prevent a downgrade? I think there are sort of three scenarios that we want to support. One is you authenticate and then you're done and everything else is unsigned and unencrypted. It's sort of the trusted environment model. And that authentication could be auth none, which means that it's basically you just assert that you are user X and then you're done, right? So this is sort of the trusted model. Or it could be an actual authentication handshake, either way. That would be the first scenario. The second scenario would be you do the handshake and you decide that you want to sign all your messages going forward. So this is tamper-proof, authenticated but not secret. There's no secrecy.
Yeah, integrity but no privacy.
Right. Yeah, those are the words. And then the last one would be everything's private and it's all encrypted. And you want to make sure that you can't downgrade from private to integrity or integrity to nothing, I guess. And I think the way that I did this before is not quite right, because it could be that I have these tags to indicate that we start encrypting or that we start signing. And I think that's not, I think that doesn't work, because you could just, the client could drop those messages and then sort of fabricate their own session from that point forward and have an unauthenticated and non-integrity verified, whatever the opposite of integrity is, untrustworthy connection, whatever. So I think there needs to be sort of a tag that says handshake done, this is what we decided, and this is a signature on that, so that you know that it's authentic. Does that sound right?
I think what you would probably do is the final message in the handshake would be basically, I'm satisfied, I'm ready to go, and this is the last message of the handshake.
So there would be,
needs to be signed.
A flag ready that has encrypted one.
Well, Marcus, that intention of handshake over and here's the result needs to be signed.
Yeah,
with
absolutely.
whatever you need to prove integrity.
Yeah, I would assume
and
that
right now it's not, I guess.
So this is what I just added this to the Etherpad. So if we have a final tag that's the ready, we're done with the handshake, and there's a flags field to indicate what mode we're going to operate in, and then a signature.
Yeah, I mean, typically that would also be the last part of the message handshake. So it would be all wrapped together.
Okay. Da-da-da-da. Okay.
And I think you had expressed concern earlier about worrying about synchronizing the end of the handshake phase with the beginning of the message passing phase, and how the two ends handle that. And I think there's a point at the end of that handshake where that side has decided it's done with the handshake, but doesn't yet know that the other side is done with the handshake.
Mm-hmm.
And so
yeah, so maybe the client says I'm done with the handshake, and the server says okay.
Well, no, I think what you would do is that you would the two sides are just the two directions would be deciding independently that, or well, not independently, but they would be deciding separately that they're done with the handshake.
I see. Okay.
So, the client sends back a message saying, I'm done with the handshake, I'm ready to proceed. But there's a possibility it might get a message from the server that is still part of the handshake phase.
So the part that I'm worried about is say they use Ceph. The client sets the method as Ceph, and then it sends an auth request that does, they're like 2 round trips where it says, I'm so-and-so, here's a nonce, and they encrypt the thing. They do that whole Kerberos handshake to authenticate each other. And as part of that handshake, they have established a shared session key.
Right.
And they've done mutual authentication.
Right.
And so it's client to server, server to client, client to server, server to client. And at that point, the client's like, great, I have a session key. I'm ready to go, and I want this session to be encrypted. Right. And so it would send a message that says tag ready with the encrypted flag and sign it. The server also has done that handshake, and it might not care whether you encrypt or not. And so it would have, maybe it sent a racing tag ready that said not encrypted. So my concern is that if they both independently declare finished and sort of assert how the session is going to proceed, then they might decide 2 different things, and then is it asymmetrically encrypted or something, or how that went right? So I guess instead I would suggest that maybe the client, once it's ready, it sends a ready and it says, I'm done with the handshake. Let's use these session flags, and then the server says okay or not okay. That makes sense.
I think if the server thinks it's okay, I think it can just proceed onwards. Possibly the next part of the next message would be, here's the start of the encrypted thing. I don't think that needs to be a separate message at that point. I think the only case is if the server thinks that it's not done or it's not acceptable or whatever, then well, I guess it's got the option to close the connection or do something really rude at that point. I think it's going to have to indicate that it's seen the message from the client, it's ready to proceed. But I think that could be kind of piggybacked on the subsequent message flow. I don't think that needs to be a separate exchange of its own.
Okay. Do you need the server to acknowledge the end of the handshake with a signature? Because it could be that the server doesn't reply. The client just says, I'm done with the handshake. Let's encrypt. I signed it, so the server knows it's real.
That would typically be part of the handshake process. I don't think that would be separate from the handshake. I think that just would be part of the handshake.
Okay, but then this needs to be, so we can call it part of the handshake, but it has to be.
This is where the pipelining, the telescoping process has to happen. So typically you would probably try to have the server send back part of its handshake in a previous message before that.
Okay.
I mean, we're trying to figure out the details of how much we can pipeline. So, Sage, sorry, can we maybe jump ahead a little bit to because how much pipelining we need to do depends on how often we think we're going to do connections.
Yeah.
And I think there's something in here about reconnect and making it faster, but I'm not sure.
Oh, there's this. Oh, right. This other part. Yeah. So my thought was that.
Oh, go ahead.
Okay. So my thought was that we would cram all the authentication stuff to the beginning. That does just authentication and does or does not start encrypting or signing. And then once that phase is complete, then we would go into the next phase. Just for simplicity, because that way, for example, if you start signing, then everything after that gets signed and you don't have to worry about the additional integrity stuff. So as far as the message flow, it's mostly the same thing as what currently happens. Right now in Messenger 1, there's a Ceph connect and a Ceph connect reply. And that message bundles in the features, the protocol version, what type of client you are, and it has a bunch of fields for the sequence numbers that are only used if it's a stateful session and you're trying to reconnect to an existing session state. And I just separated it out so that the reconnect stuff is a separate exchange. So you only have those additional little exchanges if it's a stateful session. Does that make sense?
So when you're talking about a stateful session, you're actually just talking about kind of session information that client's keeping track of.
This is the higher level messenger semantics where you are passing messages bidirectionally and lossless, so that if
sure.
So in the file system case, the client's talking to the MDS. They have a stream of messages going back and forth. The TCP connection can drop, and we can reconnect and reestablish that session and continue that flow of messages without getting duplicates or lost messages.
Okay, so it sounds to me like, okay, so that should not affect the handshake process you go through in that case to reconnect should be identical to the handshake process that you would normally do, or I mean, all of the same. You don't want to have a weaker reauthentication process there.
Yep.
And then the other parts, it sounds like for basically any connection, one of the things that you would be asserting is that you have some client identity that's you've somehow made reasonably unique, and that needs to be part of the authentication logic. You'd be asserting I am client X.
Yes. Yes, that is true. Yep.
And so my thing is that GID. Yeah. Is that in the past we've talked about needing to be able to kill TCP connections a lot more, like as we scale things up. which makes me think that maybe we want to be, and maybe we've decided we don't need to do that, but I think we still think we need to do that. In which case,
so, yeah.
I think we need to be able to have maybe not the initial connection, like the very first connection once a client turns on, but once a client has talked to an OSD during its lifetime, I think we need to be able to send a message without doing two-way communication. Like we need to be able to send on here's a TCP session that I know you are going to accept. Here's the information to make sure you accept it, and here's the data I want you to write.
So I think we can do that. In the case of talking to OSDs, you're just presenting an existing authorizer. You already have the ticket, and you're just saying, here it is. So you can pipeline the set method, auth request, and ready.
Yeah.
And just go.
So if we think that's the case,
and just blow through it.
Then I think on the initial connect, then we're okay if we do get stuck doing round trips. I mean, it's not great, but it's not as important.
Yeah, I think the round trips are where we have to do them. They're unavoidable because you actually have a nonce that's going back and forth or something.
I mean, but for instance, like. But okay, so going back now, but if we want, and in the case of, for instance, you're racing ready tags, where one of them says encryption and one of them doesn't, if we want to start tagging, like including sequence numbers in the tags, then we can say like, I'm tagging ready based off of my seek and the seek that I've seen from you. And if they conflict, then we can look at those tags or at those numbers and say, okay, the conflict is that the server said no encryption and the client said encryption, and we can just both upgrade to encryption, and that's okay. Or if there's a real conflict, then we can send another we can make a decision and send another ready that acknowledges both of them or something.
Mm-hmm.
Otherwise, we can't pipeline, and we just need to sit there and go back and forth.
Yeah,
I think you could probably actually come up with a simpler rule. You could probably do something like saying the originating side always ends the handshake process.
Yeah. So that would be tag ready, and then the other side says, okay, and has assigned that so that you know that everything after that is trusted, I guess.
And if the recipient doesn't like the originator's tag ready, then they just kill the connection, or.
Yeah. I think that's fine.
Okay.
Or we can have a tag rejected, so they explicitly say, "You suck," and then you disconnect and reconnect or something. I don't know.
But that means that every initial connection is a two-way, and you can't avoid it.
Well, sort of. I mean, I think it can still be pipelined. I think so. In the OSD case, you would send set method, auth request with your ticket, and tag ready, all pipelined, and then you'd start sending messages encrypted, right? Because your ticket has the actual session key, I think. Pretty sure, yes. And then the server would just say auth reply. It gets your auth request. It says, "Yep, I accept your authorizer, and I got your ready, and here I accept your handshake," and then and whatever. Like I think that it really is pipelined.
Yeah. Okay. So the scary thing about this TCP reconnect thing is that you've got the possibility of somebody forcing a reconnect and stuff like that, and you would like that to be reasonably. You want that to be proof against that kind of attack.
Well, the authentication handshake would happen before that, so you wouldn't trust anything that happens after until.
Right. But the other thing is that, I mean, TCP itself doesn't have any real security. There's nothing that stops an attacker from breaking a connection anytime it chooses, inserting new messages, so on and so forth. So, I mean, at layer TCP, I think you just have to assume it's not secure, and your security has to run at a higher level than that. So having the reconnect thing, or even, having a client that for some bizarre and unpleasant reason decides it's going to send every message flow in a different TCP connection is not a completely bogus concept.
Mm-hmm.
It just means that you can't use you have to have something besides the TCP connection to basically be your connection session state information.
Yeah. Well, if I'm if I'm understanding correctly, I think having this authentication exchange at the front, where you decide that you're either going to sign or encrypt, and then having everything that follows signed or encrypted, then we get that layering, right?
Yeah.
We can decide in a moment here how we actually do those signatures in a nice way, but I think, yeah, I think that works. So then the thing that I'm worried about now is how we just avoid a replay attack. And I confess I can't remember how.
That's what sequence numbers are for.
Yeah, but
that's straightforward. If your sequence number is higher than the other end, you just throw that out.
Which is fine if you're signing it, but I'm thinking about this initial authentication handshake. I can't remember. Yehuda's probably not here.
Are you talking about starting? Are you talking about a new TCP connection? You're talking about creating a new connection session.
So what I can't remember is if in our current, so currently they're called authorizers when you present a ticket, an existing ticket, like if you're talking to an OSD. And then there's an authorizer and an authorizer reply. And what I can't remember is if the authorizer is your ticket. I think it also includes a nonce, and then the authorizer reply is some twiddling of that nonce based on the service key, so you know that it's authentic. And if that's the case, then we can't pipeline all of this. There's in order to do that, there's a necessary pause. So if you look down here below, it'd be it would be the client would send the banner and the set method and auth. The server would send auth reply, and then the client would say ready, because it would need that auth reply, which includes a nonce.
For the pipelining process, what probably makes the most sense is you ignore the pipelining process. You go through, you decide all the exchanges you need to do, and then you go back and you look at which ones don't depend on the others and can be piggybacked and combined with other things.
Yeah. Okay. I think that's where it is.
Yeah.
Just basically.
So this nonce you're talking about, is that pretty much your connection ID?
It's just a random number. It's like a random 64-bit number.
Okay. You might want to make that a larger. You might want to make that a larger number.
Okay.
You want that to be big enough so you don't have to worry about birthday problems and stuff.
Yeah. Yeah. Okay. Yeah, we can reevaluate that. I think that's already done in Cephx. I think Cephx uses a 64-bit one, but it's random, so hopefully.
Yeah. Yeah,
it doesn't matter.
that's where you get the possibility of a reuse thing.
Okay. So I think that makes sense. Okay, so the next question I have then is how to do signatures. So I think I guess I have two sort of assertions. One is that the signature should be a variable length buffer because it's dependent on whatever your authentication plugin is. So in the Cephx case, maybe it's 128 bits. In the Kerberos case, maybe it's 64 bits. Who knows? Whatever. It's going to be dependent on. Maybe it's both a sequence number and a payload. Who knows what the structure is going to be? It's going to be auth mode dependent. So there's that. One, sig is variable. Sig len varies based on method. So I guess the first question is would the signature length be fixed by the method? So that as soon as we determine what method we're using, whether it's Cephx or Kerberos or something else, then the signature length for any message is always going to be 8 bytes or 16 bytes or whatever? Or is it going to vary depending? Do you have a sense?
I think it would be typically fixed length.
Okay.
I can't think of a reason why it would be variable length. Usually your messages would be variable length, but if you're breaking it apart that way, I think they'd end up being a fixed length.
Okay, good. I was hoping, yeah, I think that makes sense too. So in that case, all these things that have sig length can get rid of it, right? Here and here. And in that case, then it's basically a fixed length blob of bytes that's going to accompany every tag message thing. So I guess what I'm trying to accomplish is that all of the second whole section, the message flow handshake, and the third section which is the established session, I would like all of those to have a well-defined and simple scheme for including signatures, if signatures are enabled. So for example, maybe the tag is always followed by the signature, and then the rest of the payload is probably the thing that makes the most sense. So that way, once you authenticate and you determine what your signature length is going to be based on the method that you negotiated in your handshake, then the tag ident and the missing features, the reconnect, all of this other stuff where you're sort of negotiating the higher level exchange can be signed in a consistent, regular way where the signature, it's well defined where the sequence number is getting incremented on every tag. There's a new sequence number or whatever.
Okay, there's some advantage to putting the signature F at the end of that. And that basically means you can send a large data flow and then send the signature at the end.
Okay.
Yeah.
Okay, we can do that.
Which means that especially, I mean, I haven't ever actually worked with them, but if you have assisted send offloads or whatever, then you only need to pass through it once.
Yeah, that would, yes, that would be good. Yeah, that's actually might be something that we could offload to the NIC. Yeah. They're always asking us what we can do, and we never have anything that we can do. But yeah. If we prime the SHA-1, for example, and then we have the tag and all the data, and then the signature block could just be the SHA-1 of whatever we primed it with and that exchange of the SHA-1. That might actually be good. Okay, so that means this tag thing has all this stuff, and then there's a signature at the end here, and one, here and here and here and here.
So are we actually okay signing very short messages? Or because their content will often be known, right?
I don't know what the right way to do that is. So presumably you don't pad it out to zeros and sign it. You want to pad it
okay. You generally, many of your messages are going to have predictable patterns in them. So there's not much you can do about that. Well, there are things you can do about them, but they get really gross, and most people don't want to do those things. Practically speaking, the thing that you really want to do is make sure that let me think about this. You mostly want to make sure the beginning of your message is reasonably unique, and so if you're doing something like CBC mode, typically you would send a random confounder at the beginning, and that generates a random hash which permutates through the rest of it, so you don't end up with any predictable data blocks in the actual encryption algorithm.
Yeah, so we can't just send our tags and sign the tags.
Well, we could if we if we prime the hash function or whatever with some buffer, right? So it could be that say we're doing SHA-1 with like a 16-byte minimum or something, and we're sending a 2-byte message. We could send 14 bytes of known something and then the 2 bytes of useful stuff, as long as that 14 bytes varies per session, like it's a nonce, and the two sides agree on it. Is that right, Marcus?
You typically would be sending typically you'd make sure that the confounder that you're sending is a full block in size. You wouldn't try to piggyback anything else in it.
I see. Okay.
I think in your case, you've got sequence numbers that are intended to be unique, so I think that's something you could just send at the beginning of that process.
I mean, we could just...
Sorry, but I mean, is it okay if the input is known as long as... I'm actually not sure if this is a problem. I don't know if encryption anymore, but if the input is known and the output is known, like when you're doing signing and it's a small input, does that make it easy to break the key?
Yeah, it does. It makes it easier is the right way to phrase.
Well, so I'm worried about having like a tag and then a 64-byte flags and then a signature. That seems like it's way too easy to break the key out of.
Right. Unless we pad the block out. So what you would sort of naively do would be pad the block out with zeros. So if you're sending 3 bytes and your block size is 16, then you'd have 13 zeros at the end.
Okay.
But what we can do is pad it with a deterministic confounder that is unique to the session and is rolling. So it could be like the signature of the previous message, but not the signature, but something that was signed, some state from the previous message, I guess. However, maybe it's the previous signature, like hashed with your session key or something, right?
Okay. I think it is more usual to send a completely random confounder that's not based on any other information, and just include that as part of the hash.
But it can't be random because the other side has to know what it is.
No, it can be completely random. If
then how would the signature?
If it's not encrypted, then it can be random because it's sent in plain text.
Oh, I see.
And then once it is encrypted, then you can include a random thing in the previous message and carry it forward. That's how perfect forward secrecy or whatever works, isn't it? Or whatever that technique is, where you embed the key in for the next message.
That's a different problem, but yeah,
it's a different one. But I mean, that's what it does.
Are you saying that like on say line 122, this tag is it's only LE64, so it's only 8 bytes. We would just add another 8 bytes of random gibberish and then sign it.
Yeah, pretty much. Except that you'd be sending that first. I mean, if you're doing CBC mode, each cipher block depends on the cipher block that's. I'm sorry. Each block that you're encrypting depends on the block before that. And it's not your data; it's your data plus the ciphertext of the previous block.
Okay. So maybe then what actually happens is that when you choose your method, 2 things happen. You fix the length of the signature itself, and you also fix the message block size or the encryption, the block size.
Well, I think another thing you could say is whatever you're doing with confounders and stuff like that, that could be part of your encrypted. That could be just part of the encryption protocol that you've negotiated. That doesn't need to be part of the message data logical message structure. It just needs to be part of the physical structure.
I think. Okay. Well, I think what it means. I'm not quite sure if all of that, but let me just. I think what happens is that say we negotiate CephX. We decide that our signatures are 16 bytes, and we also, because of CephX, a fixed property is that our block size is 16 bytes because we're using whatever. I don't actually know if that's the right number, but let's just say that's what that is. That means that when we go to send, going down here, like line 123, tag ident missing features or something like that. This is a short message. It's less than 16 bytes, and so there's an automatic padding of random goop that just gets stuck. That gets shoved to the front or the back, whichever, out to whatever that minimum block size, if it happens to be shorter than the minimum block. Does that make sense? Or am I looking at this backwards?
I think you can't encrypt less than 1 block. However, if you're encrypting at least 1 block in size, there's a clever scheme where you don't actually you can set it up so you don't have to actually add extra data for the encrypted part. There's something called ciphertext stealing, which does that.
So in this one above,
yeah,
this tag ident is more than 1 block, so we wouldn't have to do any padding. So it's only be on the ones that are shorter than.
Well, if you're always sending a confounder and the confounder's block size, you never have the problem of having a message that's too small.
Okay.
Yeah, we need to make sure we actually do that because like with these tags, we have very short tags, and so they're not a block size. A lot of these.
Right.
Yeah. That's.
So I'm saying that our sort of low-level code that says like send this tag and this payload will just automatically cram in some randomness if you're less than 1 block.
I think it would always cram in that randomness. That would be your confounder. You'd probably do that regardless.
Well, you'd only do that if it's shorter than 1 block, right?
Well, you want to send that. You send that confounder anyway, because that way the beginning of your actual message will always be different. Right.
Okay. So you'd have an automatic confounder after every tag
probably before, at the
block
beginning of
size
each
minus 1.
block, or each exchange, or each message flow. Yeah.
I see. Okay. And it would go everywhere. I see. Okay. That's simpler.
And so is it okay if we don't sign the tags, or do we need to sign the tags, which means we need a confounder in front of the tags?
Well, I think that the signature, we can just define the signature to be like the byte of the tag and the confounder that pads it out to one block, and then everything else.
Well, so I don't know how important this is, but Marcus is emphasizing that we want to start with the confound. We don't want it in there. We want to confound at the beginning. Now, I guess what we could do is once we receive it, we can swap the tag and the confounder in our memory for the signature portion, maybe.
I see. Does that order matter there?
Well, for the wire encryption, you want to make sure that the order is confounder first. How you store things in memory or whatever is a completely different question.
Okay.
So I guess we.
I mean,
we are about the speed. Then we can put the confounder second, but do the signing with it first.
Well, I think you might as well sign it with it second too. But is there any case where you would not want your tags to be part of your encrypted and sequence checked logic?
I think we probably do want to sign them, because otherwise I have no idea what it is, but I think you get up to mischief by swapping the tags and making use of signed data to do something else.
At least in the current Ceph protocol, the tags are kind of basically part of your framing structure that indicates how the beginning of a message or whatever. I think in this new scheme, I'm not sure that you would necessarily have tags in that sense.
I think you do, because we have this message flow handshake negotiation where we are sending these little mini messages around. And then even after we establish that and we're sending messages, we have acts, we have keep alives, and we have keep alive acts. We still have
so you have a couple of different data flow types. Okay, fine. Yeah.
Okay. So if you go way up to the top of the pad, then I think.
Yeah, I don't have the pad open. Sorry, but
it's in the. I'll paste it in the chat. It's in the chat.
Okay, cool.
Then you have the authentication phase where you have C or S, and they send a tag byte and a payload. And then you have C tag ready and S tag ready. Okay. And then you have
the nonce thing. I thought we decided we needed a nonce handshake in between, so it wasn't pipeline.
I'm just leaving in the thing, leaving out the actual contents of it. That's the message, because it's down below. But the high level, this is sort of the high level view of the thing, is the authentication phase has a bunch of exchanges that are sort of unsigned tag payload exchanges that finally culminate with a tag ready and tag ready OK. That include a signature. And then everything after that, it becomes it becomes the confounder plus a tag byte plus a payload plus a signature. Does that make sense?
Are we okay if the nonces and things aren't signed on initial transmission?
They are. I'll copy it. Sorry. They're sort of explicitly signed as part of those messages.
Yeah. Okay. Yeah.
So it looks like that. And I guess actually these should include a confounder, huh? And a signature. Are you seeing this, Marcus?
I'm trying to figure out I apparently don't have the right IRC channels on this machine. I'm trying to figure out what I have to do for that. I'm sorry.
It's in the BlueJeans chat. There's a link to the Etherpad.
Oh, so it's in the BlueJeans chat. Maybe let's see. Where do I get that?
On the right-hand side of the screen.
Oops. Okay. There we go. Right. What did that do? I don't know what that did. There we go. Yes. Okay. Thank you. Okay. Well, I have it open now. So.
Okay. So let's sort of go through it. So the initial part, the banner phase, the connection opens and both ends just sort of spam their Ceph and then the protocol feature bits. And you can wait to see that. And if you don't see it, then you hang up, or you can sort of assume it's coming. And then if you get something else, then hang up, whatever. I think that you sort of pipeline that, but that's pretty simple. Then there's the authentication phase, which are messages going back and forth. There's a tag byte and a payload. They're in the authentication section below. This is where you set a method and you do the actual authentication handshake. The payloads are sort of self-authenticating and self-signing, depending on what plugin it is. So if it's CephX, then you're sending your challenge and response within all that stuff. That's all sort of self-authenticating. And assuming you finish that process and you're ready to go, then the client sends a ready, which is going to include a confounder, the flags that say this is how I want the session to go, and it's going to sign that message hopefully with whatever it is negotiated during that initial handshake. And the server is going to reply with, great, I agree, and I signed my agreement, or whatever. Does that make sense?
I don't think you need I don't think you need the confounder as part of this initial exchange. I think that's something you would do once you've completed and you're doing your regular encrypted session.
Well, I want to make sure that this signature is valid. Right?
Oh yeah, you want to do all that stuff. The problem is,
in the case of CephX, then this is actually being signed with sort of a common key, so it needs to be well protected.
Yeah, well, it's the session key that we negotiated during the previous exchange, but we want to make sure that the thing that we're signing is confounded, right? Because it's a short message. Like we don't want them to be able to fake the signature or brute force it to figure out what the session key was or whatever.
how big is your session key?
I think it's a 16-byte AES key.
Okay, I would think your handshake complete thing might be at least 16 bytes.
Well, right now it's just 64 bytes. It's just the flags.
I think that's probably plenty big.
Not 64, sorry, it's 8 bytes plus 9. It's 8 bytes, which are predictable, right? It's usually always, it's going to be 0, 1, 2, or 3. Not even that, it's going to be 0, 1, or 2. Because you're not going to encrypt and sign.
Okay.
So you don't include a confounder. Okay. Yeah. The server will reply, okay, I agree. I'm just going to send back the same flags. Just actually, that probably is unnecessary, but it'll just sign an acknowledgement. And then everything after that, then the structure is a confounder, which is just the block size, the tag byte, the payload, depending on that tag byte, and then a signature. And based on what we negotiated before, the block size and the signature size have been fixed based on the method. Yep. Okay. Okay. I think that's good. That makes sense to me. Let's see. Somnath's question forever ago was, our current message signatures are still significant degradation of performance. It's true. Partly that's just because of the way that the code is structured. Partly it's because it's just stupid. And partly it doesn't matter because our current signatures aren't really secure anyway, because they're signing a CRC, which isn't secure. So I think the question is, how are we going to make these signatures fast? And I think the way to do that is to choose, first of all, we would choose a secure hash function like SHA-256, probably, or SHA-1 maybe, but probably not SHA-1, I think.
Anything like SHA-256 or whatever is going to be much slower than CRC.
Yeah.
Yeah. Yep.
Yeah. No, I mean, at the level someone else talking about, sorry, yes, this will cost you IOPS. It's just slow.
Yep.
I mean, we can do our best to make it so that you can put it on offload engines and things, which will make it faster, but
yeah,
it's still going to be a lot more than 0.
So I think
Blake 2.
Yeah. So I think what we can do is
yeah, I'll be right back. I have a couple of things to take care of.
Okay. It seems like there are sort of two things we can do. One, we can just be careful about what signature function we choose, so that it's one that is optimized on processors that people are using. And I don't know what ARM does here, but I know the new Intel processors either have or are going to have like acceleration for SHA-1 and SHA-256. I don't know how much faster it goes than whatever, but that helps. And then if we can make sure that, I think the way that this flow is structured, it should be amenable to offloading to the NIC. But we might want to go poke whoever it is that keeps asking us about NIC offload. I actually don't remember who. It's probably Mellanox, I guess, and others. Ask somebody there whether this is like the right overall flow to be able to do that.
I mean, it's data that we're signing. I guess we need a hardware person in here, but and you, I don't know. Do you think this goes with that talk we saw about the offload engine at Vault? Does this work for that? That's probably the model we care about.
That was encryption, but they have a very similar. I can't remember. I think the ISAL, the Intel Storage Acceleration Library, the same library we use for erasure coding and CRCs. I think that has encryption stuff. ISAL Intel Library. Let me see what is in there.
Well, I mean, I assume this is the same. We're going to be doing the same thing for encryption as we are with this. It'll just be that.
Yeah. Yeah.
Now, what's interesting on encryption, I guess, is that maybe we don't actually want to acknowledge what kind of messages we're sending, or do we want to try and hide that? And it should just be like have a message prefix, and then the tag and everything is encrypted as well.
I think it's yeah. I don't know. My guess would be that we would just want to encrypt the entire stream. Like it would just be you establish the key and then it just goes.
Okay. So that means that basically all the tags have to get filled out to a.
We need to pad things out to
Well, most of your tags are going to be followed by a message, so you don't have to pad those. You just your message.
But we want to flush it out on the wire. We might have like 17 bytes, and we're like push that over the wire to the other end. And so the easiest way to do that is because we don't want the flushing boundaries to be like to semantically change the way that you're running the cipher. We can just fill out blocks with random garbage and push them out. Right?
I think you won't need to do that, but sure.
Because, right, I mean, if I say our block size is 16, and I have I have two 20-byte messages, or say I have two 24-byte messages. If I send both of them back to back, then I'll have 3 blocks. It'll go over the wire, and everything is fine. It's well defined how that gets sent over. But if I want to send the first 24-byte message and then wait 10 seconds and then send the next one, and I want the first 24 bytes to go over the wire, like you can do that ciphertext borrowing thing, but then that changes the result at the other end based on my flush boundary.
Yes, it would.
Right.
Yeah.
Okay. So we want to pad. Okay. So I think that means that that means we have sort of two schemes. If signed and not encrypted.
I mean, you'd have to know your message boundaries no matter what.
Yeah, but if it's signed, they don't have to be padded to block boundaries. Oh, maybe we just keep it simple and always
How
pad
do you
out.
how do you plan to know where your message boundaries are?
It's sort of defined by the tag byte and the payload that follows. Like it's defined by the stream. It's not known ahead of time. So it might be that you always have a confounder block size, and then you also have some extra block size plus some, right?
I think that's going to get complicated because it means you're going to have to start decrypting things before you can figure out how big things are so that you know how much to decrypt.
Yeah.
That's going to
maybe you start with your confounder, and then at the very end you have more padding block size. Is that simpler?
You're going to start with the confounder and how do you know where the end is?
That's defined by all the stuff in between. Or you could have a U32 in here that's the length.
Sure. Yeah, something. Yeah.
And then you have padding out the block size, and then you actually know.
Yeah.
Right.
Well, I mean, someone can just sit down and do this, right? So.
Yeah, I guess so. Yeah. So if this is signed.
Oh, yeah, sorry.
If it's signed or encrypted, then we do that. Else, it's like really simple, I guess. We just don't. We have what we used to have, basically.
Yeah.
Which is just tag byte and payload. Okay.
Maybe. Yeah. So if we want to do like a reconnect, even if it's not a like higher level reconnect, if it's just like I was connected to you before and our TCP session died, how do we make that roll without roll in so that it's pipelined? Do we want to just have like a predictably increasing, like a predictably mutating nonce, so that they can just be like, hey, I was previously connected to you with this nonce, and now I'm connecting again, and here's
that's the connection idea I was talking about earlier. I think as you're part of your initial exchange, one of the things that you would have probably both ends do is assert that it's some random identity. Possibly a UUID or something like that. And if it's going to reconnect and it believes the other end has a session active, then it can presumably just say, I'm so and so, I'm picking up where I left off. Here's my sequence numbers.
Yeah.
And one possibility it needs to allow for is that the other end, if it's, for instance, this is a client reconnecting to a server, it's possible the server's gotten rebooted. And so the server may just not have connection information anymore, at which point it has to fall back and do the full exchange.
Yeah. Now I'm also worried about, you don't want to be able to let people replay that if it's only signed. So we need to I think every time we do that, we need to include a new one that it uses for subsequent reconnects.
Well, sorry, hold on. I don't see how this is related to the authentication handshake, because this reconnect portion happens after you authenticate.
No, this.
Well, a reconnect needs to include authentication, like replay the authentication pieces, or at least enough authentication to prove who it is, and that it's not a replay attack.
Yeah, on the server side, it has to start off looking like a regular connection, because it won't know that it's a reconnect until the client tells it that that's a reconnect. So it has to branch off from the initial authentication logic.
So after you would connect, you would authenticate, finish, you do your ready, okay.
No, that's what I'm saying.
And you say, okay, I'm authenticated. You now trust me. Now I am reconnecting to this particular session that you should know about.
See, if we're in, sorry, this is a little bit separate, but like if we're in a world where we are like we have more clients connected to servers than the server can support, so it's dropping TCP sessions a lot, then we don't want to do that round trip for every client IO or whatever. So we need to be able to, like, within the same message, basically say, I'm this guy, take my message, even though it's a new TCP stream.
So I don't think that we can avoid, I don't think we can securely authenticate without a nonce.
Yeah, that's
Otherwise
what I'm saying. So they need to have some remembered share state, even if the TCP stream goes away, that they can both that it can like assert and sign on.
I see. Oh, do we have to?
Well, I mean, if we think
okay.
TCP sessions can be long, if we think we're not going to run out of TCP scalability, then no, then we don't.
Well, okay. So
I thought this was a thing we were worried about. maybe not.
Well, let's consider for a second what would happen if we don't do that. So if we keep the authentication separate, you have the client has to wait for the auth reply before it can send its ready. But at that point, it can send the reconnect and the start and the message without waiting for the server.
Yeah, but it means that if we have
only one
more client than the server can handle, then basically on every op, then we're waiting for 2 network round trips of latency instead of 1.
We already have like 2 round trips for TCP anyway, right? Isn't there like I can't remember what the flow is, but isn't it like hello? I mean, there's already at least 1 round trip before you can actually start sending data.
You don't know exactly what's happening. That's going to be hidden inside the kernel, and there are actually implementations of TCP that can send everything all in one go.
Oh, really? Okay.
Yeah.
Okay.
But I think from your standpoint, I think what this would look like is the server would start off not knowing that this is a reconnect. It would send its initial banner. If we're going to take Greg Farnham's approach, then the first thing the client sends over is probably, it won't be quite a regular message, but we probably some very short thing that says, I am client UID blah, probably unsigned. It's probably just that's what's there. And then the very next thing it does is it keeps right on going and has a regular message.
Oh, and
there are 2 possibilities. One possibility is the server will take a look at that and say, I've rebooted. I don't know anything about you. We have to start over again.
Mm-hmm.
And the second possibility is that the server can say, oh, I know who you are. I'm just going to keep right on going.
So it could be a
that probably means that
continuation of the previous session. Then it would just it'll be a little bit like the sequence number won't line up necessarily. So it'll be like a slight rewind, but it can still be
that initial thing that you're sending over should include actually it probably should include here's my session and then here's an encrypted copy of the sequence numbers that I have at this point, all as one block.
I see.
And one of the possibilities is the server might look at that and say, well, I've seen bigger sequence numbers than that from you before. This must be a replay attack of some sort.
Mm-hmm. Or it's within some window or something.
Something.
Oh, no, but if it's bigger then that would never happen. Right. Okay. Yeah. Okay. So that would be like we would have a new message that's like fast auth ready, which includes LE64 flags. There's a cookie. Who am I? And there's some signature and some sequence number. I don't know. There's going to be a bunch of stuff, right?
Yeah.
Okay. And that would basically take the place of the auth handshake and ready. And then the server would reply with tag ready. Okay. Something like that.
Yeah. Presumably you could make this a special, just a special sort of it would just be another path for your authentication handshake. I mean, this is a handshake too, so there's no reason it can't be just another type of handshake.
Yeah. Okay. That makes sense to me. What I like about this is that we can add this later. This is just an extra message thing that we can add after the fact.
Yeah.
Based on one of those feature bits or whatever. Why do we just sort of combine them? Okay.
There's another implication of this too, which is when a TCP connection closes, you wouldn't know right away that you can throw away the state that's associated with that.
Yeah, you would have a special message that says, "I'm gracefully closing this. Throw away my state," or something like that. Okay.
Any different from what we already do, is it?
I don't think so. Except I think we don't actually implement they. Oh no, we do. It's
do.
the higher level. The higher level throws away the state, but the low level doesn't actually induce the throwaway of the state. If that makes sense. There is a tag close, but we don't actually use it.
Remember.
Yeah, it's sort of. I remember only this annoying.
Yeah.
Okay, so I wonder if there's one thing that we maybe should add then. It's in the tag ident around line 160. Maybe we should add a cookie field. That is like, this is my end's unique identifier for this session. And so the client, when it sends it, it would be that cookie. And on the server, it would also have a cookie. And that could be used later on, for example, during this fast auth. And also, or if you're doing the slow reconnect, it could be used here.
Well, the fast auth needs to use something supplied by the trusted or the more trusted endpoint. So I think the server needs to supply whatever is used for the fast auth.
Right. That's what I mean. So the client would say, "This is my identifier for the session," and the server would reply with, "This is my identifier."
Oh, I see.
And the client could use that when it's reconnecting. So it could be a random number.
Okay.
It could be a pointer. Like who knows what,
so when the server sends it, then it's like, this is a cookie for you, not my cookie. Okay. Yeah.
Yeah. What happens right now is that implicitly, the unique identifier for the session is the entity adder T, which is like super lame. Because we have to have this big hash table of all the IP addresses mapping to connections. And also because we're going to change this so that we can have multiple addresses for an endpoint. Yeah, a client identifier, exactly. So this would sort of separate it from the address thing, so you can identify the session with a unique value.
I think you can get by with using randomly generated UUIDs, and I think you could let clients pick their own. I don't think you need to have the server assign that.
Well, if it's provided by the client, then it can be used in a replay attack, can't it?
That's right. And if it
one.
That's why your reconnect logic has to have some authentication that goes with it.
So hold on, I'm not.
Yeah.
Oh wait, yeah. Sorry, no.
The client chooses it. I'm saying the server chooses it. The server chooses its identifier for the session, and the client chooses its identifier for the session.
Yes,
not
that's right.
Equal. And that's a replay.
And then on a reconnect, then the client would send the server provided one.
Yeah.
No, the client would resend its client side chosen one, just like it did originally. And if it knows the session information on the server, it will successfully reconnect. And if it's trying to steal a session, it won't know that and won't be able to reconnect.
If it's trying to steal a session, how will it not know that if it witnessed it earlier?
If it's trying to steal a session, it should not be able to do the reconnect. It should not be able to succeed in doing the handshake.
But it'll fail there because it went with the signature, not because it doesn't know the identifier.
That's right. Yeah, exactly.
Right. So here the cookies we're suggesting are sent in the clear. Like
that's right. Yeah, okay. That's right. They're clear. They're known. They could be stolen, and it has to be up to the handshake process to make sure that can't happen.
Got it. Okay. I think we agree.
Okay. And probably clients should be somewhat prepared with the notion that they might have to regenerate their client identifier every so often, because they should never pick one that another client has picked. But if they do, they should be prepared to abandon and start over.
Well, okay, we don't agree then, because I think what we're suggesting is that the client doesn't need to pick it; the server picks it. But it picks it randomly.
I think it's okay for the client to pick it.
Well, if it's sent in the clear, then we want this to be part of the authentication. Is that?
Yeah.
Yes. So we can't have signed it previously, because if it's signed in the clear that someone sees and it's a thing that the client has already signed, then it can be used to steal. So we need to not let that happen.
The client side's cookie, the only value that has is it hashes into the server's session stash.
So that's what we're saying. We don't actually care about the client-side cookie unless it's a fast reconnect.
Exactly. Yeah.
Right. Yeah.
So it's using data from the server that has not been previously signed. So it's a thing that on an initial connection is meaningless, and on a fast reconnect, it has not previously been signed by the client, so no one knows what the signature is supposed to look like.
Right.
So it is actually it is replay proof.
Yeah.
And
then
you would need to get like a new cookie once that happens in case for your next reconnect.
Right.
That the server could supply.
Right.
Again.
Now, the one catch is you probably when the client is connecting to multiple servers, it probably shouldn't expect to be able to use the same cookie for all the servers.
So
no, not at all.
So what I'm saying is that if the important thing is that it's unique on the server, not that it's unique on the client. So just let the server pick it. Like it can, then it doesn't have to be a UUID. It can be 64 bits instead of 128 bits. It doesn't have to be fully random. It could be, like I said, it could be an incrementing value. It could be a pointer. It could be, who knows what it is.
Well, it can't be incrementing because otherwise it actually does have a good chance of colliding with other servers.
Well, no, the server would increment it.
But if the server's incrementing it, then it actually does have a good chance of colliding with the same client on other servers.
But if on a reconnect, it will be based on the.
Well, this data structure is going to be the same except for the cookie to every server you send it to. So if the cookie collides between servers, you've got a problem.
The signature should be different though. Like if I have two OSD sessions that have an identical exchange, the signatures will have different prime. They'll be primed with different nonces.
Is it at this point?
Well, if we do this right, then the first time you connect to the OSD, you do this. You do tag auth and tag auth reply, and that has the authorizer and the authorizer reply, and there was a nonce in there, and you use that nonce in initializing the signature and the session key that you're using for that exchange, and so they will be different.
Okay.
They have a random seed.
I think you're making this more asymmetrical than it needs to be.
Well, ignoring the cookie thing for a minute, we definitely want, if we have two identical sessions to two different OSDs, we want them to have different signatures and different.
Yeah.
Right. We're using the same ticket to initiate both connections, but there's a nonce during that initial handshake where I present my ticket and get a response that gives them separate session keys.
Yes.
And those are used for signatures, so all the signatures are going to vary.
Yeah.
Okay.
We don't have to worry about. So even if the cookie is predictable.
Sorry, right. I forgot this wasn't being signed with the same cluster key data. Okay.
Yeah, I forgot that too. Okay. So it's a client identifier assigned by the sender. Switches out of the server or the client, whoever's sending that message.
Yes.
Okay.
Yeah. And it's probably just an auto increment. Increment. Okay. Or a random value, whatever, as long as it's unique.
Yeah, I would say unique value and leave it at that.
Yeah.
Okay. Are we good with our protocol as far as anyone's thought it through?
I think all this reconnect stuff is fine because it just mirrors exactly what we did in Messenger 1. I think the start message we don't need anymore because it was originally intended to signify the end of the handshake, but we already sort of signified the end of the authentication handshake. I don't know what flags we would additionally want to set. And so we can probably just start sending messages. I don't know. I mean, we could keep it in there just in case, but since we don't have flags defined, then I'm not really sure what.
Yeah, no, I think having a handshake complete message that's your part of your last handshake flow will do everything you need.
Okay, so we should keep it then. And the message, How I had a few small changes here. I forget what it is. Oh, it's the ACK ID, ACK sequence number. So we can avoid having explicit ACKs most of the time. The next message would just sort of implicitly ACK whatever else there was. I think that's it.
I mean, that's okay as long as we actually have other messages going back and forth.
Yeah.
Which we
and if we
might.
don't, If you don't, then you could always just send an actual ACK message. But most of the time you do, and so this avoids that extra. The problem is that it's that extra syscall and context switch or whatever. I don't know.
Yeah.
It's adding latency in the async messenger.
Yeah.
Okay. So that's good.
So implementation-wise, it sounds like this is mostly a mutation of our existing messengers, right? Rather than a whole new one, which means that I think we really, really want to do it. I know you kind of don't, but I think we really want to do it in the simple messenger as well.
Yeah. So we should discuss that. I guess the question is, what additional value does it give us to have two implementations of this? Have it in the simple messenger.
Seems like it gets us a great deal of negative value. Why do you want to do it in simple messenger, Greg?
Well, I mean, one is that it's still sort of the reference for. I mean, we can say it's not, but it's still sort of the reference value. Are you kidding me, or are you okay?
Huh?
Just you were adjusting your camera, and I thought you were smacking me through the internet.
Can I do that?
The new button in BlueJeans.
So, I mean, at least right now, like the simple messenger is still sort of the reference, and if this is a mutation of the protocol rather than a new protocol, however loosely that means, yeah. But I mean, then I think we should include it in our, like, we should build it off of our reference.
I think this would destabilize the simple messenger as much as the async messenger is already unstable. I think that by the time this goes in, we should remove the simple messenger from the code base.
I would like to go in before that happens.
I mean, but by the time the release comes out where this is the default, I don't think the simple messenger will even still be in the code base.
The simple messenger has a built-in problem that it has the insecure CRC implementation that you would always have to support as long as you support the simple messenger.
Mm-hmm. Well, async messenger mirrors that, so we can still support the legacy. We can still support the legacy protocol with the async messenger. So the thing that I like about
adapted to, or is it well adapted to XIO messenger and what it wants to do, or does it need to do?
Isn't XIO completely 100% different?
It is. We'll need a way to mirror these capabilities.
Oh, I see.
Yeah. So my hope is that everything we've defined here can be sort of easily mapped onto XIO messenger. I think we want to have the same authentication handshake, probably, unless we're just going to live authentication in the XIO messenger entirely, but it's probably not what we want. So I don't think anything here is going to make that different. It doesn't have to follow the exact same protocol, but I would probably suggest that it just do because it's sort of well thought out, I guess, and it's defined.
No, of course, we wouldn't want to do anything to it twice. The XIO messenger doesn't do the little binary. I mean, doesn't do back and forth sends and receives the way the simple messenger did. But we're not doing them here, right? We've kind of got higher level messages now for everything.
What do you mean by binary back and forth?
These tags and signatures are still happening at the same level as the existing simple messenger protocol.
Still a flow. It's very similar.
Okay, then
what the messenger is doing.
So I'll have to figure out how to. So it wouldn't make it. Doesn't select. That's not something that XIO messenger knows how to do right now. My hope was in the next version it would be able to send and receive some high level essentially messages that could be encoded and decoded and would have these payloads.
I mean, that's kind of that's what it does, right? These tags each tag block is a message.
Okay, so we'll just need to recast this, and it'll just be a breaking change, but it would be an improvement.
Yep.
Yeah, if they look like messages, then it's great.
So going back to going back to the simple messenger async messenger thing. So what I like is that the overall structure of the async messenger, because it's a state machine, is going to make it much easier to implement this old protocol side by side with the old one. Trying to implement this in simple messenger is going to be a huge amount of work, and I can't really figure out when we would want to use it. I guess. The only argument I can see for it is that we might want like an independent implementation that we can make sure they talk to each other to like verify that our implementation is correct.
Yeah.
But like, I don't know if it's worth it.
No, it's not worth it.
All right.
And also, we're gonna need a second implementation anyway, the kernel one.
That's true.
Right?
Yep.
That's true.
Yep.
Yeah. I mean, I don't know. I'm also just more conservative about the async messenger than you guys are, and if we think it's going to be ready that soon, then fine.
I believe also that the exercise of implementing this will teach someone, Craig, the async messenger, to become happy with making it.
Well, no, that's fine. I guess there's two things I'm thinking. One is that from a greedy employer perspective, I don't get the impression that we think the async messenger is going to be ready to be a default for the next releases. For
I think it's
at least one and maybe other downstreams.
Okay. We should just make it default now.
Yep.
I mean, all right. So we're not.
Like,
it's been running in the nightlies. We have like a bug that came up in the CERN cluster, right?
Mm-hmm. I think it's fixed.
Now's great. Let's make it default. Screw it.
Okay.
So,
and the other one was
Greg,
that I thought we still had some not a lot, but I thought there was still a performance regression that we weren't sure how to fix.
And we also have huge performance improvements due to models and stuff too. So it's
all
like,
right, then maybe we're in great shape, and we shouldn't.
Well, but we're at the beginning of the cycle for the next stable release. Now's the time. If not now, when? Right.
Okay.
Yeah.
Greg, I have a question for you. If we were looking for a correctness implementation, it doesn't really seem like Simple Messenger is the one to like do that in. I mean, it seems
so async messenger is actually a state machine. Like I've almost not looked at any of the code. I thought it had like taken the Simple Messenger implementation and copied and pasted it into the right.
Nope.
Right.
There are bits of code that got cut and pasted, but they're like the pieces that run without blocking. Got put into the appropriate section of the state machine, moving from state A to state B.
Okay.
Which is why
if it's actually a state machine, then yes, we should do it there. That was going to be my other question. Was like, if it's not a mutation of the implementation, then we should make a real state machine out of it. But if we already have one, then
it is.
Never mind. That's a good plan.
Would it be worth having some kind of basically really actually simple reference implementation that doesn't care about performance?
No.
I mean,
okay.
If we maybe if we actually had competing messenger implementations beyond the Simple Messenger and the async messenger, like if we actually had different people working on them, maybe. But
we were seriously worried about someone else implementing it, then that might be a concern. But we're not, and it's just not worth the trouble.
Yeah.
Sure. Fair enough.
Plus, we'll have two implementations because of the kernel one. It'll be fine.
Yeah, that's true.
Yeah. Well, we'll have kernel, we'll have XIO, and we'll have async.
XIO is a completely separate thing. It does not have the same protocol.
Yeah.
We will mirror elements of it because why do the same work twice? But it's not the same protocol.
Yeah.
Okay.
If someone shows up with a new messenger implementation for a new stack, then yay, then you test it when it arrives.
Yeah.
Well, I mean, it seems like they probably adapt the existing async messenger one rather than write a new one. That's kind of my point. We don't really have that thing where new products keep having to implement our protocol.
Yeah,
they
like if we had
the library.
Yeah, it would be kind of nice if we had what's Lester's thing, LNet or whatever, but we don't. So who cares?
Well, every so often someone shows up on Ceph and is working on a wire protocol, on a wire implementation of Messenger. If they appear.
There is one other thing that we might want to consider. The Google Summer of Code student 2 years ago implemented a Wireshark protocol dissector for Messenger 1. So it would be awesome if maybe another Google Summer of Code student or somebody updated that.
How does that work if you have a truly encrypted connection?
It won't.
Okay, like is there any way to? Yeah, okay.
No.
You could turn off encryption.
Yeah, exactly.
Yeah, I mean, so if it's signed, you can. But
yeah, exactly.
I was wondering if there was some way where you could like inject the encryption keys and get stuff in there.
Yep.
That would not be worth it. I think.
Yeah, not unless you're at the NSA or something.
Hey, seriously, back to that topic. Blake 2, look at it. It's actually fast.
What
Oh,
is
really?
it?
I thought that was a joke.
No, it was not a joke. It's actually pretty good.
Okay.
What 2?
Blake 2.
Oh.
It was one of the runners up for SHA-3, and it's much faster. Well, Blake was. Blake 2 is the revised version of it, but
I think we should use the least interesting possible hash. The one that the most people agree is the right answer.
Yeah.
Probably.
Also, I'm pretty sure that 1 gigabyte a second on an Intel Core is not very fast. I could be wrong, but I'm pretty confident.
There are lots of implementations. Interesting.
Yeah.
Greg, if you find something that's significantly faster than that, I would be happy to read about it.
All right. Maybe I'm just misinformed. Anyway.
Well, I mean, arguably, right? If we're really serious that if people are doing this, they're going to have like a hardware offload engine for SHA-2 or something, then okay. But
yeah,
I mean that's basically what Intel's AVX is. It AVX? Whatever Intel's.
No.
I mean, the thing that's most likely to be hardware accelerated is probably what we want, I guess. But no, whatever.
Yeah.
Okay. I think that's it for this topic. I'm satisfied. I think now we just need to start coding.
Yeah.
I'll send out a final email summarizing, clean up this document a little bit, and then put it in RST form, I guess, and then we can go from there.
Hey, Sage, hit me up before you send that email out. I'll have the video up, and you can link to it in case people want to go back and revisit.
Okay. Okay. We have 4 minutes left. Is there anything else anybody else wants to talk about? 4 minutes.
We're 26 minutes over, so people are going to keep talking if they want. But yeah.
Oh, never mind. I thought. Okay. Sounds good. All right.
Cool.
Thanks, everyone.
Thanks all.